Earth, our planet, our home. Here we continue with our lives, deal with our problems, appreciate its beauty and gaze at the night sky. Some of us wonder what it would be like to visit each celestial object, imagining traveling through space and seeing them up close. So let's do it. Let's pause our lives down here for a moment and leave our planet behind to venture into the cosmos. When we return, perhaps we'll see it differently. Our first destination will be the closest celestial body, the Moon. Bright and splendid, it has generated many myths and legends. Its gravity causes the rising and falling of tides on Earth. It's covered in craters. From up here, its details aren't as noticeable, the scars left by millions of asteroids and comets that have impacted it over billions of years. Some are small, simple bowls, others are enormous, tens of kilometers in diameter, punctuated with a peak in the middle that formed when the material from the gigantic impact that created it splashed back up. Some are strange. The Moon has its own beauty, ancient lava rivers, beautiful mountainous landscapes. Some mountains rival Mount Everest in height. 12 people have left their footprints, since there's no wind to erase them, they'll remain there for millions of years. We've barely left our planet, and we can still see it 238,900 miles away. Our next destination is a bit farther, 6.2 million miles, 18.6 million miles, 25.5 million miles. Venus appears harmless at first glance. On Earth, it shines in the east in the morning and in the west in the evening. Known as Earth's evil twin, it's almost the same size, but it's a toxic inferno, incredibly hot with crushing pressures on its surface. It's the hottest planet in the solar system, up to 880 degrees Fahrenheit, hot enough to melt lead. Its dense atmosphere traps heat. Here it rains sulfuric acid, but it's so hot that the droplets evaporate before touching the ground. Spacecraft have survived only a few hours after landing on the planet, they are destroyed due to the extreme conditions. Lava flows carve enormous serpentine channels. Let's head toward the Sun. The closer we get, the more intense the heat, but first let's make a stop at Mercury. The planet closest to the Sun is extremely hot, but also extremely cold. During the day, the planet's surface can reach about 800 degrees Fahrenheit, and at night it plummets to minus 290 degrees. Mercury is small compared to Earth, but it has a powerful gravitational pull. It's very dense, almost as dense as Earth due to its enormous metallic core. The Sun is fascinating. We depend on it, it's our light, our heat, our energy. We're so far away that its light takes 8 minutes to reach Earth. About 1.3 million Earths could fit inside the Sun. It's very hot on the surface, an extreme heat of about 10,000 degrees Fahrenheit, but this is nothing compared to its center. The conditions are infernal, about 27 million degrees Fahrenheit. Moreover, the pressure is so extreme that hydrogen atoms fuse to form a heavier element, helium. In the process, a huge amount of energy is released, equivalent to detonating 400 billion 1 megaton nuclear bombs per second. If we move away a bit and block all the blinding light, we can see the corona, a stream of subatomic particles moving away from the Sun. It extends for millions of miles. On Earth it can be seen during a total eclipse. The surface is chaotic. It's so hot inside the Sun that electrons are stripped from their primary atoms in the gas, creating what's called plasma, a soup of charged particles. Their movement generates a powerful magnetic field. The plasma glows due to the great heat, but as it cools it dims and settles on the surface, producing a dark spot. The plasma on the surface can also flow along magnetic circuits. This can create enormous arcs of material. These fire arcs extend for thousands of miles across the Sun. If the conditions are right, a giant short circuit is created and all that vast stored energy explodes outward, a solar flare. It's interesting to think that our lives depend on this infernal world. Let's continue to our next destination. Mars, the red planet, has captured our imagination for centuries. It was once thought to be the god of war. How many science fiction novels and movies have been made about Mars? Today it's one of the most explored worlds in our solar system. We've learned a lot, a curious world of diverse landscapes, a place where life could have existed. From here we can better appreciate the highest mountain in the solar system, Olympus Mons, an ancient volcano 16.8 miles high, 3 times higher than Mount Everest. Imagine the view from the top. Valles Marineris, a system of canyons up to 6.2 miles deep, stretches 2,485 miles from east to west. The Grand Canyon is tiny in comparison. We couldn't survive here without a spacesuit. The atmosphere is very thin. The surface pressure is less than 1% of Earth's pressure. The air is mainly carbon dioxide. During the day, temperatures can reach 68 degrees Fahrenheit, but at night they plummet to -99 degrees. However, the atmosphere is substantial enough to interact with the surface. Winds blow seasonally, filling craters with dust. They also blow the dust, creating beautiful dunes. On this world, sunsets are blue. The time is approaching when humans will witness these sunsets in person. Perseverance, in addition to searching for signs of ancient life, has been testing technologies that will aid human exploration. Many minds are working right now to bring humans to Mars. On the way to our next destination, we encounter many asteroids. We're passing through the asteroid belt between Mars and Jupiter. It contains about 1.9 million asteroids larger than 0.6 miles in diameter. Some are over 310 miles in diameter. They are rocky remnants left over from the formation of our solar system. Jupiter, the largest planet in the solar system and one of the most spectacular. It has a diameter of 88,846 miles. It's so vast that all the other planets could fit inside it. It's a monstrous, toxic planet, with thousands of large hurricanes. Inside, the pressures are extreme. Its immense gravity attracts thousands of asteroids and influences the characteristics of its moons. This monster possesses great beauty. It looks like colorful abstract artwork. Turbulence within the bands creates storms, giant vortices that rage in the clouds with fierce winds of hundreds of miles per hour. There's one that rules them all, the Great Red Spot, a colossal hurricane much larger than Earth that has lasted hundreds of years, with sustained winds of 310 miles per hour. All of this is just the top part of the planet. Inside, conditions become really extreme. Its atmosphere is very thick. The strong winds penetrate thousands of miles down. The Great Red Spot extends downward about 186 miles. The temperature and pressure increase more and more with depth. Further down, the gas becomes thicker and hotter, and eventually turns into a liquid, an ocean made of hydrogen instead of water. Even deeper is where things get really strange. Instead of a mantle like terrestrial planets, Jupiter has an enormous region formed by metallic hydrogen. At these extreme pressures, hydrogen undergoes a strange transformation. It can conduct electricity like a metal. Here it's hotter than the surface of the Sun, about 18,000 degrees Fahrenheit. Its great gravitational field retains many moons, a total of 79 moons. The ones of greatest scientific interest are the first 4 moons discovered beyond Earth, the Galilean satellites Io, Europa, Ganymede, and Callisto. Io, this colorful moon, catches the eye. It has many active volcanoes. It's the world with the most volcanic activity in the solar system. This is because it's between the gravitational pull of Jupiter and 2 other moons, Ganymede and Europa. A frozen world, Europa. This is one of the most promising places to find extraterrestrial life. Beneath its icy surface is a huge ocean of salt water. Jupiter's gravity is creating friction in the interior, heating the ice until it turns into water. Ganymede, the largest moon in the solar system, is even larger than Mercury. Like Europa, it could also have a subsurface ocean, but much deeper below the surface. Callisto is full of craters. It may also contain a subsurface ocean. Saturn has captivated our imagination, one of the most amazing planets. It's not the only one with rings, but none have rings as spectacular and complex as Saturn's. It's a gas giant, the second largest planet in the solar system. From afar the rings look solid. If we get closer, we can see that they're actually made up of countless small pieces of water ice. Each particle orbits the planet independently, like millions of tiny moons. Despite their size, they're incredibly thin, with an average thickness of only 33 feet. They possibly formed when a moon was torn apart by an enormous collision. Since Saturn is oblate in shape, there's more gravity at the equator, so they're perfectly aligned in that area. Some particles are larger. You can see how they interact with the rings, creating waves as they orbit the planet. When small moons orbit Saturn in slightly inclined orbits, they can create waves in the rings, tremendous vertical excursions that can reach several kilometers in height. This gas giant is similar to Jupiter. Inside, the pressures are extreme and it has many storms. At its north pole there's a rather strange one, an enormous hexagonal vortex. Although it seems quite unusual, vortices like this are common on planets. Saturn's moons are very interesting. This one looks like a planet with an atmosphere, the great moon Titan, the second largest in the solar system, larger than Mercury. It's an extraordinary world. It's the only world besides Earth known to have liquids in the form of rivers, lakes and seas on its surface. This moon is icy, so icy that gases like methane and ethane are liquids. This world has clouds, rain, rivers, lakes and seas of liquid hydrocarbons. These lakes and seas could possibly harbor life that uses a different chemistry than what we're accustomed to, that is, life as we don't know it. Enceladus, this icy moon has great possibilities of harboring life. Like Europa, it has an ocean beneath its surface. Geysers expel water vapor and organic chemicals from that subsurface ocean into space. From now on, Earth will be so far away that it will be impossible to see with the naked eye. These worlds we'll visit remained hidden throughout history. Uranus, the cold and windy ice giant, has one of the strangest climates in the solar system. It has the coldest atmosphere of all the planets, -371 degrees Fahrenheit. The pressure inside the planet can break methane molecules, compressing the carbon in them so much that it forms diamonds that fall to the base of the mantle like shining hailstones. The planet is so tilted that it essentially orbits the Sun on its side and also rotates in the opposite direction. It has two sets of beautiful rings. We're getting further and further from Earth and we've barely begun our journey. We arrive at the most distant planet in the solar system, Neptune. Dark, cold and whipped by supersonic winds. We're far from the Sun, here its light is dim and takes 4 hours to reach us. Neptune has the fiercest winds in the solar system. These incredible winds whip clouds of frozen methane across the planet at supersonic speeds of 1,490 miles per hour. And that's it, the last planet in the solar system. We feel less and less of the Sun's heat, we see less of its light. We're very far away, but there are still several worlds to explore, the dwarf planets, worlds that are too small to be full planets but too large to fall into smaller categories. There are many dwarf planets orbiting the Sun, we'll visit a couple of them. Pluto, smaller than Earth's moon, has a heart-shaped glacier the size of Texas. This fascinating world has beautiful mountainous landscapes, but with red snow. It's very cold, with temperatures from -375 to -400 degrees Fahrenheit. 3 times farther from the Sun than Pluto, we find Eris. Not much is known about this world, but we know it's extremely cold, dark, and probably has a rocky surface similar to Pluto. We're 6.2 billion miles from the Sun. From this distance, sunlight takes more than 9 hours to travel from the Sun to us. We haven't even left the solar system. It's a small point in the vastness of the cosmos. It's time to leave it behind. Interstellar space, we're very far from our Sun, it's difficult to differentiate it among the great number of stars. Billions have planets and moons like our Sun. The distances are so great that if we traveled at the speed of light, it would take years to reach our next destination. The number of miles is incomprehensible, we have to use another measure, light years, the distance light travels in a year, 5.9 trillion miles. With so many options, it's hard to decide where to go. Let's start with something close, its light takes 4 years to reach us. We have to travel a bit faster. Alpha Centauri, they're so close together that from afar they look like a single star. In reality, this is a system of 3 stars. The third, Proxima Centauri, is quite far from these two. Alpha Centauri A and Alpha Centauri B, 2 stars similar to our Sun, travel through space orbiting one around the other. Proxima Centauri is a red dwarf, it contains only about 1/8 of the mass of our Sun. This planet orbits it, Proxima b. It's a bit larger than Earth, perhaps it has life. Kepler 452, a star similar to our Sun, has several planets. This one is similar to Earth in size and is in the habitable zone, where it's neither too hot nor too cold. Life could exist. What would it be like? It's hard to imagine. We've gone very far. We're 1,400 light years from Earth. There are several interesting things we left behind. The Seven Sisters star cluster is a characteristic feature in our night sky. At 410 light years away, it's clearly visible from Earth. It has captivated many minds throughout history, it originated a Greek legend. The Pleiades are the 7 daughters of the Titan god Atlas and the sea nymph Pleione. During an ancient war, Atlas rebelled against Zeus, the king of the gods, who sentenced his enemy to forever hold the heavens on his shoulders. The seven sisters were so sad that Zeus allowed them a place in the sky to be close to their father. The Pleiades are an example of an open star cluster, a group of stars that were born almost at the same time from a gigantic cloud of gas and dust. The monstrous star Canis Majoris is incredibly enormous. Our Sun is 109 times larger than Earth. That's quite large, but it's nothing compared to this gigantic star, 950 times larger than our Sun, more than 100,000 Earths in diameter. One of the largest known, a red supergiant. It's in its final stage, about to explode. It will be a huge supernova. A cosmic work of art composed of a star that was once like our Sun. Now a dying star lies at the center. When it finished burning its fuel, the ancient star expelled its outer gaseous layers, leaving behind a tiny, hot, and dense core called a white dwarf. The dusty outer layers of the star dissipate into space, glowing from the intense ultraviolet radiation expelled by the hot stellar core. The Orion Nebula, a huge cloud of gas and dust in space with a size of 12 light-years. Created by supernova explosions, many stars are forming here. The turbulence deep within these clouds gives rise to knots with enough mass for gas and dust to begin to collapse under their own gravitational attraction, forming stars. It's sculpted by stellar winds expelled by young stars that emit powerful ultraviolet light. The most famous supernova remnant, the Crab Nebula. When a star reaches its end in a violent and fiery death, it throws its innards into space, creating an expanding wave of gas and dust known as a supernova nebula. At its center is a pulsar, a neutron star. It's so dense that a teaspoon of material from this star would weigh 4 billion tons. It rotates very fast, once every 33 milliseconds, firing beams of radio and visible light that spin like a lighthouse in space. The nebula extends 10 light-years in diameter and continues to expand, more than double the distance from Earth to Alpha Centauri. From now on, the scales become difficult to comprehend. This nebula looks like a bubble 7 light-years in diameter. The boiling star that's forming it is 45 times more massive than our Sun. The star's gas gets so hot that it escapes into space as a stellar wind, forming the outer edge, giving it a bubble-like appearance. An asymmetry between the beam makes it off-center. What spectacular views the cosmos offers us, each one seems like a natural work of art. The Pillars of Creation. This name is due to it being an active region of star formation. Within the nebula are hundreds of newly born stars. If we look at it with infrared light, we can distinguish them. A group of young stars bathe the nebula with ultraviolet light, showing us its details. Their winds slowly erode the enormous clouds of gas and dust. What could be our next destination? Our galaxy is very large. We could spend our lives looking at each interesting object. There's a distortion in the light. What could it be? A black hole, one of the strangest and most fascinating objects in space. They are extremely dense and have such a strong gravitational pull that not even light can escape their reach if it gets close enough. A place where gravity exists in its most intense and overwhelming form. They are born when a sufficiently massive star reaches its end. This one wanders alone through space, practically invisible because there's no material falling into it. Its immense gravity distorts the light around it. Now let's go to the center of our galaxy, a truly extreme place. You can see a dense cluster of stars in the center. If we speed up time, you can see that they're orbiting something. It must be extremely massive. A supermassive black hole, Sagittarius A, 4 million times more massive than our Sun. A large amount of superheated material orbits at its speeds close to that of light. The surrounding region is a cosmic tornado. The extreme deformation of space-time around it plays with our vision. The extreme gravity bends the path of light emitted behind the black hole and makes it seem that the accretion disk is also above. In real life, we couldn't reach many of the destinations we want to visit due to a phenomenon known as dark energy, which pushes bodies in the universe away in such a way that they become practically impossible to reach. Those bodies move further and further away, making the observable universe smaller and smaller. All this time we've been breaking the rules of physics and the limits of spacetime to reach our destinations. Now we'll travel so far that some places would be totally different if we travel to them instantaneously. The light that has been seen from Earth of our next destinations is several million years old. So, to make things less complicated, now we'll not only travel great distances, we'll also travel back in time to be able to see each object as it was when the light reached Earth. This way, at some point we'll reach the beginning of everything. Our galaxy is full of interesting things. We've seen only a few, We could spend an eternity exploring billions of stars, billions of planets. But we have to move on with our journey. We have to go further, into intergalactic space. From here it's as if Earth never existed. We can't even say it's a small point in space, it's invisible among so many stars. And now each point of light is a galaxy, each with billions of stars and planets. This really makes one feel small. Now we have to expand the scale of everything. The distances are now millions of light years and the sizes will be hundreds of thousands. Let's move on. Our neighbor, the Andromeda Galaxy, is 2.5 million light years from Earth. It's enormous, measuring 220,000 light years, much larger than ours. From Earth, in a fairly dark sky, it can be seen with the naked eye as a spot larger than the full moon. Our galaxy and the Andromeda Galaxy reign as the most massive and dominant within the local group of galaxies. In the future, this galaxy will collide with ours in about 4 billion years. The universe is very large. Each destination is further and further away. At 13 million light years from Earth, what's happening with this galaxy? It's quite irregular, its disk is distorted. Enormous hydrogen clouds in the shape of flames sprout from the central region. Millions of stars are being born there, 10 times faster than in our galaxy. It's believed that the interaction with its neighboring galaxy has triggered the Great Stellar Burst. At 20 million light years, this galaxy has an extra pair of arms that can be seen here in red. Normally spiral galaxies only have one pair of arms. Those two red arms are made of very hot gas instead of stars. They seem to be the result of the violent stirring of matter around the large black hole at its center. At 23 million light years, the Pinwheel Galaxy. The giant spiral disk of stars, gas and dust is 170,000 light years in diameter. The galaxy's spiral arms are dotted with large regions of nebulae. They are areas of intense star formation. The universe has its own beauty. At 25 million light years, the elegant Whirlpool Galaxy. Its structure may be due to the gravitational action with its smaller companion galaxy, which can be seen right next to it. Numerous clusters of young and bright stars stand out in red. They are the result of the gravitational influence of the companion, which is triggering a great star formation in the whirlpool. At 30 million light years from Earth, this is an iconic galaxy, the famous Sombrero Galaxy. Its hallmark is its bright nucleus. It's white and bulging, surrounded by thick lines of dust where many stars are forming. They shape its spiral structure. At the center there's a smaller disk. A large amount of material falls into it. A supermassive black hole of 1 billion solar masses resides there, as in many galaxies. There are many interesting galaxies. We can spend a lot of time contemplating each one. They are imposing and beautiful. Let's go further, much further, so far that the distances will become difficult to comprehend. On this journey, the rules of time are different for us. We've been traveling back in time, millions of years back. If we continue, at some point we'll reach the origin of everything. At 100 million light years from Earth, we've traveled 100 million years back to see this peculiar galaxy. It's the result of a galactic collision in the distant past, that's why its distorted appearance. Two luminous extended tails are signs of that collision. At 250 million light years, a magnetic monster, a galaxy that's surrounded by enormous reddish filaments. It has an eerie appearance. The filaments are suspended in a magnetic field that maintains their structure. It demonstrates how the energy of the central black hole is transferred to the surrounding gas. The filaments are so large that light from one end would take years to reach the other. A ghostly galaxy with a background of distant galaxies. Its uneven structure suggests that it may have been part of a dramatic collision at some point in its relatively recent past. It's a lenticular-type galaxy, intermediate between an elliptical galaxy and a spiral galaxy. It has depleted or lost most of its stellar matter, therefore, it has very little ongoing star formation. We're witnessing a pair of galaxies in a celestial dance. Long tails of stars and gas emanate from each galaxy due to the great gravitational forces. Eventually they will merge into a single giant galaxy. We're 400 million light years from Earth. This strange galaxy seems to be running through space, leaving a long tail of stars and gas behind. In the background you can see thousands of distant galaxies. Its distorted shape was caused by a small intruder, a very blue and compact galaxy that's fleeing. The strong gravitational forces of the interaction created the long tail of stars and gas that extends more than 280,000 light years. We're getting further and further away, further and further back in time. It's time to go much further, billions of light years away, billions of years in the past. A zoo of thousands of galaxies. We're seeing a sample of the deep core of the universe as it was billions of years ago. A great variety of galaxies of different shapes, ages, sizes and colors. The smallest and reddest may be among the most distant known, existing when the universe was only 800 million years old. The closest, the largest and brightest spirals and ellipticals, developed about 1 billion years ago, when the universe was 13 billion years old. These galaxies narrate a period when the universe was younger and more chaotic, order and structure were just beginning to emerge. From now on we'll be exploring unknown territory. All this time we've been exploring places that we've seen from Earth with our instruments. They're not yet advanced enough to see beyond for now. However, mathematics and physics are quite precise, they give us an idea of what we haven't seen yet. We've already seen the first galaxies. If we go further back, we'll see the first stars, a universe where galaxies didn't exist yet, they haven't formed yet. Further back we reach a dark and cold universe. Stars don't exist yet, they will emerge when gravity gathers masses of gases that will become more and more compact and heated in certain places until they form the first stars. Hundreds of millions of years further back, almost at the beginning of everything, we reach a chaotic universe of ultra-hot matter, 9 billion degrees Fahrenheit. An explosive expansion is being triggered. Protons, neutrons and electrons will later form atoms, the raw materials that will become everything that exists today. Beyond that, 13.7 billion years ago, it's difficult to comprehend, something completely unknown. Possibly the entire universe condensed into an infinitesimally small singularity, a point of infinite density and heat. What's beyond? What happened before? Perhaps we'll never know, but our minds won't stop imagining. Our human curiosity will lead us to find the answers to everything that exists and doesn't exist for generations. We have to return home. Our lives await us on our small blue planet. After seeing all this, we feel very small. Time feels very slow. That blue dot, that's us. On it is everyone you love, everyone you know, everyone you've ever heard of, every human being who ever lived and lived their lives. The sum of our joy and suffering. Thousands of confident religions, ideologies and economic doctrines. Every hunter and gatherer, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, every hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a speck of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our postures, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes, settle, not yet. Like it or not, for the moment the Earth is where we have to stay. It has been said that astronomy is a humbling and character-building experience. Perhaps there is no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another, and to preserve and cherish the pale blue dot, the only home we've ever known.